I hope everybody can hear me and see me okay. Seeing me is not important. As long as you guys can see the board okay, it's fine. Yeah? Okay, cool. So basically the entire board is visible to everybody. Yeah? Alright. So one last time we'll do a quick roll call and we'll get started. So we have Ahana, Akshita, Nanya, Datta, Dheera, Kirti, Neil, Nikhil, Praneet, Ritika, Sara, Vijay and Viva. Some kids are still missing, but we'll get started. Now, the question is, what is that we want to learn today? So as I had mentioned in the group chat, we will look at how do we prove one of the theorem that I talked about in the last class, and then we'll start with unit circle trigonometry. So, okay, I see Ria also is here. Okay, Dave is here as well. Alright. So, as I mentioned, we will try proving the theorem that we talked about in the last class, which is relating to circle theorem only. And then we will start with the unit circle trigonometry. For some of you who have been part of pre-calculus class, unit circle trigonometry will sound very familiar to you because we have done that in that class. Treat that like a revision, or anything that is that comes up new will become a thing that we learn. Alright, so let's get started. So remember in the last class I was talking about, we were talking about circle theorem and we dealt with few problems relating to that. What I was saying was, if you have a circle, be careful with the wire, and I would need help from one of you to close the door. So in the last class we were talking about circle theorem. That is where we talked about how do you find out the length of the arc, how do you find out area of the sector and those stuff. Do you remember that? No? Okay. So who doesn't remember, we'll have to watch the video of last class just to see what did we do. There's nothing fancy about it. Circle theorem says that okay, if you have a circle, if I talk about circle theorem, there has to be a circle. And you take 2 points along the circumference of the circle. This area is called the sector. And how do you find out the area of the sector? Which will be a function of how much angle it is making at the center against 360 degrees. That is how you find out the area of sectors. Do you want to notebook? No? Sure? Okay. And then if you have to find out the arc, length of the arc between these 2 points, this will be a minor arc, this will be a major arc. So if you have to find out this minor arc, you will see okay, how much angle it's making, and that is what portion of the entire 360 degree. That is what we learn, and that is what we are supposed to learn as part of circle theorem. You guys remember that? Now, in the last class when I was talking about it, and when we were doing some problems, I told that if I have a circle and I pick 2 points, the angle that these 2 points make at the center, this angle is half of the angle it makes anywhere. So let's say this angle is 60 degree, any point you pick around the circumference along the major arc, okay, or the other side of this angle, this will be 30 degree. And there's a reason for it. It's not because I'm saying so, it's based on some mathematical reasoning. And this is what we'll try proving it, just to make sure that you guys have no doubt. What I'm saying is this is magical. You pick this point and join these 2 points. This angle will also be 30 degrees. You pick this point. You want to play the extremes. Join these 2 points. This angle will be half of this angle. And is that something that you guys are already aware of, or it's going to be a new thing that you come across? And be honest, it's okay. If we are learning something new, that there's no harm in that. Datta, Kirti, Dheera, what do you think? Is this something that was known before, or you are coming across for the first time?
I knew about this.
You knew about this before? Akshita?
It's something new.
Okay. That makes me feel happy. When there's something new I'm teaching you guys, I feel happy about it. How about Praneet? Okay, so let me not do a lot of cross question, okay? A lot of cross question is not a great idea. So, what I'm trying to say is, if I have 2 points, P and Q, and O is the center of the circle. If I join the center with these points P and Q along the circumference of the circle, okay? This angle theta. If I randomly pick any point anywhere without any consideration, I just pick the point along the circumference on the other side of this. What I'm saying is, this angle will be theta by 2. And how is what we will see now. Wow. How, now, and wow. Okay, let's find it out. I will join these 2 points. Let's say PQ and this was R. If I join R with the center, now what do I have? I have 2 triangles. Triangle OPR, R, and I have another triangle OQR. Yeah. If this is not very intuitive, I'll add some color to it. So what you are seeing is there is a green triangle and there is a blue triangle. The green triangle is OQR. So this is your green triangle. Okay. And OPR is your blue triangle. Is it at least readable to everybody? Is it making intuitive sense? Okay. Ananya, Ahana, everybody okay? Kirti, Dev, Neil, everybody? Okay. Alright. Now, what I'm trying to force you guys to believe is this blue triangle and this green triangle are congruent. Do you think so? Why?
It's because so RQ and RP are the same because they're both the diameter. And then
RQ and RP, no, they're not the diameters.
yes, they are because they go across the circle.
No, so see, if I'm drawing 2 lines, this one, they're not they'll be diameters only if they cross the center. They're not crossing the center.
It's because RO is shared. And
RO is shared, okay.
and then
This is radius, so these 2 are same.
And then
What else?
I don't know. I'm too tired
Okay.
of this.
Anybody else? I'm saying that these 2 triangles are congruent. Any reason? So what are the circumstances under which two triangles will be congruent. You have four options. You have four options. You have SSS, SAS, ASA and RHS. Yeah? There are four theorems of congruence, right, for triangles. Praneet, is it making sense, beta? Is it, if I am saying that this triangle and this triangle are congruent, are you guys going to believe it? No? So now, if you guys are able to believe it, can somebody tell me why? Which theorem it's aligning with? I have this side being common between this triangle and this triangle. This is radius, this is radius. So two sides are also same. What else? So far we have just got two angles being same. Sorry, two sides being same. And we have not talked about angles yet. So which theorem is saying that these two triangles are congruent? Yes, Achita.
Is it SSS?
Well, so this side and this side, on what basis we can say they are same? I mean, I have not given any confirmation. I have not given any clue with respect to we believing that they are same. Right? I'm just making you guys think a little bit more about it. Anybody else? Datta, Dheera, Nikhil, Dev, Vijay, anybody? Ananya, Ahana, anybody? I'm just trying to make you guys think. And you know what? Right? Yes, Datta, go ahead.
I think this could be SAS probably because
Okay.
it's just two sides and then the angle could be.
Okay, so right now this side is common between both the triangles. This one and this one both are the radius of this circle. So they are same. Are you saying that this angle and this angle are same?
Yes.
On what basis?
Because the reflexive property.
Say that again?
Reflexive property.
Okay. No. Yep, you're saying something.
No.
Okay, here's the clue. Here is the clue. Now look at this. Let's say if I'm looking at the blue one, I'm looking at the blue triangle. Okay? What is happening? This side and this side are same, right? Because this is radius, this is also radius. That means this angle and this angle will be same. Yeah? Similarly, this angle and this angle will also be same if I'm looking at the green triangle alone.
So that means the middle angle has to be the same.
I'm sorry?
That means the middle angle has to be the same.
No, so they are same within themselves.
Yeah.
Even if I pick up another point here.
Oh, like not in respective to each other.
Right. So, now what's happening is, let me change the course a little bit here. Let me change the course here a little bit. Here, guys, here. Look at this. Let's forget about this theorem of congruence. I have an easier solution for you guys. Okay? Now, if you look at this triangle and this triangle, the green triangle and the blue triangle, what we are seeing is this angle and this angle are same. And sum of this angle plus this angle will be equal to what? This angle. Let me give it a name. This is 1, this is 2, this is 3. This is 4, this is 5, this is 6. Okay? I'm I'm changing my plan. I found an easier solution for this one. Okay? Forget about this. Now look at the green triangle. 2 and 1 plus 3. 1 angle 1 plus angle 2 plus angle 3 is equal to 180 degree. Agreed? Let's say this is 5. This is 5. No, this is not 5. Up to 6 we have already consumed. So this is 7 and this is 8. Okay? So 1 plus 2 plus 3 is 180 degree. And angle 3, this one plus angle 7 is equal to 180 degree. They are making straight angles.
Wait, what?
Angle 1 plus angle 2 plus angle 3 will be 180 degree. Agreeable? Angle 3 plus angle 7, I just stretch this line a little bit more. 3 plus 7 will be 180 degree.
Yeah.
3 is common between the two. So 1 plus 2 is equal to 7. 1 plus 2 is equal to 7. Angle 1 plus angle 2 is equal to angle 7 here. Sum of the 3 angle 180 degree, this angle plus this angle 180 degree. That means these two angles will be equal to this angle. Come to the blue triangle. 4 plus 5 plus 6 is 180 degree. Now, angle 6 plus angle 8, 180 degree. Angle 6 plus angle 8 is equal to 180 degree. So from this we can conclude this 6 is common in both the equation. That means angle 4 plus 5. So this plus this is equal to this. So angle 4 plus angle 5 is equal to angle 8. There's a little bit of thinking needed. Forget about the congruence part for now. I have found an easier way to prove it, so that's why I'm leaning on that one. So what I'm saying is, we have to, let me start the journey from beginning, and then you guys will be able to relate to it. Everybody can hear me okay, right? Nikhil, Leela, Katie, everybody. What we were trying to prove, we picked 2 points P and Q and connected that with the center. It forms some angle. Now what I'm saying is, pick any other point anywhere on the circumference and connect with that. So we picked point R, connected P with R, connected Q with R, and it made some angle. What we are trying to prove is, this angle is half of this angle. Okay? So for doing that, what we said, okay, now let's join P, Q and R with the center. And that kind of constructed these two triangles, one green triangle and one blue triangle. If I am looking at the green triangle alone, angle 2 plus angle 1 plus angle 3 will add up to be 180 degree. Yeah? Now, when I stretch this line further, angle 3 and this angle 7 will make 180 degree straight angle. That means this and this is 180 and this is 180. That means this and this is equal to this. From the first green triangle. Now come to the blue triangle. Same thing, I am repeating myself. This plus this angle. 4 plus 5 plus 6 is 180 degree. And if I look at along this line, angle 6 plus angle 8 also adds up to 180 degree. That means this angle is equal to this plus this. Yeah? I'll pause here just to make sure that everybody is with me. Achita seems comfortable with whatever I said. Gira, everybody, Vijay, Pani, Neil, Sarah, everybody okay? Ananya? Now, so we have two equations. We are saying that angle 4 plus angle 5 is equal to angle 8. And we are also saying that angle 2 plus angle 1 is equal to angle 7. 4 plus 5. Okay. Angle 4 plus 5 is equal to angle 8. Angle 1 plus angle 2 is equal to angle 7. Now, this angle 1 and angle 2 are same because they are part of the isosceles triangle. In the green triangle, these two sides are same, so these two angles will be same. So angle 1 and angle 2 are same. So instead of writing angle 2 plus angle 1, I can write this as 2 times angle 1 equal to angle 8. Yeah? 2 times angle 1 equal to angle 1 plus angle 2 equal to angle 7. Angle 4 plus 5 equal to angle 8. 4 plus 5 is angle 8. 2 plus 1 is angle 7. So, by angle 1 and angle 2 are same because they are part of the same isosceles triangle. These sides are same, so angles will be same. So I can say instead of angle 2 plus angle 1 equal to angle 7, I will say 2 times angle 1 equal to angle 7. Similarly, in this one I will say 2 times angle 4 plus angle 4 and 5 both are same because they are part of the isosceles triangle. This side and this side same, so this angle will be same. So instead of saying 2 times angle 4 plus 5, I can say this as 2 times angle 5 is equal to angle 8. Am I making sense? Sahit here. So by looking at these equations, we see that this angle same. So I can say 2 times of this angle equal to this angle, 2 times of this angle equal to this angle. So 2 times of this angle plus this angle will become the total angle, will be equal to this angle. I am going to pause here for 10 seconds to see if it at all made sense to everybody. Neel, Ananya, Dave, Dheera, Kirti, and kids, remember one thing, you don't have to say yes if I am not making sense, okay? I do horrible job many a days. So don't say yes, don't give me a thumbs up if you have slightest of doubt in your mind. Nikhil, are you clear with that?
Yes, sir.
Okay, no, I'm just checking generally, okay? Randomly I'm checking. So from this whole thing, we kind of dug a whole mountain to find a mice. But more conceptually, you are not forced to believe that, okay, this angle will always be double of this angle. Be this point here, be this point here, be this point here, be the point here, be the point here, be the point here. Unless you are coming here in this range, any point you pick up and join these 2 points with this angle will be half of the angle it makes on the center. This is the theorem that I was talking about. Ahana, did that make sense, brother? Okay. Alright. I see some kids are missing. Jesse is not in the class. Okay. How about Ria? Ria, did it make sense so far? Ria, Ritika, Vijay. Okay. Divan, Vishal, everybody okay? So this was all about this theorem which says if you pick any point on the circumference, the angle that it makes on the center is double of the angle it makes by joining these 2 points on the other side of the circumference. Okay? And you can use that for solving all angle relation problems whenever you come across. Okay? So, with how many minutes? Almost 25 minutes being spent, one thing we have learned or agreed upon is, if ever I come across a question which says, I have a circle, this is making 135 degree at the center, find out the value of this angle that you make by joining these 2 points. You will not even think about it, not even blink your eyes once, you will see it will be half of this. 62 point or 67.5. 135 divided by 2. Yeah? Is that okay? Alright. So now I want to start with unit circle trigonometry. And many of you who have been in the pre-calculus class, like I said in the beginning, would be comfortable about these concepts. So it will be a recap for you guys who have come across this in the past as part of pre-calculus class. But for everybody else, it will be something interesting that you'll get to see today. So, everybody is fairly comfortable with what is trigonometry, right? Friends, here. Everybody is fairly comfortable with what is trigonometry concepts. And if I ever utter the word Sokatua, that will not sound like a word coming from Mars. Okay? Now, let's muddle the water a little bit and try to convince ourselves why do we even need to worry about so many new things coming our way? What is the purpose it solves? So let's say if I talk about a right angle triangle. As soon as I talk about right angle triangle, this has one angle is 90 degree. Let's say this is side A, this is side B, and this is side C. First thing that will come to your mind is Pythagorean theorem, A square plus B square equal to C square. Agreed? Yeah? Now, so if you know two sides, you can find out the length of the third side. If you know this side and this side, you will be able to derive this side. Or if you know this side and this side, you will be able to derive this side. So net the idea is, if you are talking about a right angle triangle, if you know two sides, you can derive the third side, applying Pythagorean theorem. Now, as long as we knew the sides, it was fine. Now we know only one side, let's say, and you know one angle, theta. That is when trigonometry came into light. That okay, you can relate the sides and the angle to find out the remaining dimensions. Now you will say Sokatua. And again, this might sound like a story to everybody, but it will help you relate to it. I mean, why the hell we are even learning new things, right? Sorry for using wrong word, but yeah. Why we have to spend so much energy and time to learn something new, right? Now, if I know this, if I knew two sides, I was able to apply Pythagorean theorem and find out the third side. Now we know one side and one angle. If trigonometry was not known, if Sokatua was not known, there was no way I could find out this side or this side. Okay? But Sokatua says, okay, you know what? You can use the angle and one of the side. Sine of theta is equal to sine of theta opposite side. Let's say this is x and this is, I will say this is x and this is y. Sine of theta is equal to opposite side by hypotenuse, y over c. Cos of theta is equal to adjacent side by hypotenuse, x over c. Tan of theta is equal to y over x. So we got another mechanism in the form of trigonometry which says you can use these trigonometric ratios to find out. If you know the value of sine theta and you know the value of c, you can find out y. If you know the value of cos of theta and you know the value of c, you can find out x. If you know the value of tan of theta alone, you can find out this ratio y over x. Yeah? Is this story sounding relevant to everybody? Yeah? So, I'm sorry?
Like water.
Here like water?
Yes.
That's coming from, that's the sound coming from this meter. Okay, so we went from basic Pythagorean theorem to leverage SOHCAHTOA to find out the other missing properties with respect to angle and side relationship. Life was good so far. Till we were dealing with, see, if you look at a right angle triangle, what is the maximum value of an angle? 90 degree. If somebody says, find out the value of sine 90 degree, you will say, okay, fine. I have that angle in this triangle.
That's one.
It's what?
Seven. I know that.
Find out sine of 150 degree. Life gets interesting. Yes, Vishal.
Is it negative 1 half?
So, could be, maybe, may not be, but I'm actually not rushing for getting the answer for this one. What I'm trying to get you guys guided towards is that we are constrained by the angle up to 90 degree to find out any of the trig function values, because trig function that we have learned as part of SOHCAHTOA only goes up to 90 degree. If I'm going to 91st degree, we don't have any way to do it using whatever we know so far. Yeah? And that is where the unit circle trigonometry comes into light. I saw somebody had raised hand, that was Vijay. Yes, Vijay, you were saying something?
Yeah, I was going to ask if you were asking the sine of 90 or sine of 150.
No, so I'm still telling you a story only. Say, okay, fine. If you know two sides, you can apply Pythagorean theorem, get it. If you know trig functions using SOHCAHTOA, you can go all the way up to 90 degree. If you have to go beyond 90 degree, that is where the third mechanism or the tool comes into light, that is called unit circle theorem. Yes, Vishal.
I was saying, I if 1 half, I got 1 half.
Okay. So we'll decode that further, okay? So now, for everybody who was enjoying my story, what I'm saying is, all that we are doing, right, is that the whole idea is to find out the dimension, the property of the shape that we're dealing with, right? So, we talked about Pythagorean theorem, we talked about sine, cos, tan, trig function, trig ratios, whatever you call them. But we were constant to deal with only up to angle of 90 degree. As soon as we hit an angle beyond 90, we don't have a choice, because there is no triangle, no right angle triangle with angle more than 90. So if we have to find out value for sine 210 degree also, there is nothing that we can do. Somebody has to find out the value of sine
502 and 3.
6290 degree. There is no triangle that can have this much of angle to apply SOHCAHTOA.
So that's trying.
That is where unit circle theorem, unit circle trigonometry comes into picture. Yeah? And we'll go deeper into it, but has that story stayed for you guys okay so far? Riya, Nikhil, Vijay, Akshita, everybody okay? Ahana,
Yes, sir.
Sarah, Neil, everybody okay? Divan. So now the magical thing is this unit circle trigonometry, which gives us a very interesting way. And this gives us the ability to go beyond 90 degree as well, to find out the value of trig ratios, sine 290, 250, 240, whatever you have to do. We can use the unit circle theorem, unit circle trigonometry for dealing with them. Now let's see how it works. Let's say this is a circle in a coordinate plane. This is x-axis, this is y-axis. And this circle has a very unique property. The property is, the radius of this circle is 1. Mr. Davik and Sahib. Being playful is good, but be here. This circle has a unique property that the radius is 1 unit. Be it 1 centimeter, 1 inch, 1 mile, 1 yard, doesn't matter. But 1 unit. And we are visualizing this circle in a coordinate plane where the origin of the coordinate plane coincides with the center of the circle. What unit circle says is any point on the perimeter is having x coordinate as cos of theta and y coordinate as sine of theta. And this theta is the angle that it makes with the positive of the x-axis. Okay? This theta is the angle that it makes with the positive of the x-axis. So if you come to this point, unit circle remains predictable and says, you know what? Your x coordinate is cos of theta, y coordinate is sine of theta, and this theta is the angle that it makes with the positive of x-axis. So you have traveled this far to get the value of this. What you will do is, you will look at, okay, in the coordinate plane, on this point, what is the length of my x? What is the x value? That will be same as cos of theta. What is the y value? That will be same as sine of theta. Okay? This is what unit circle says as a concept. What I am saying is, tomorrow if you have to find out sine of 250 degree, you will travel along this unit circle. You will travel by 250 degree, 180 plus 70, and find out this point. This point's x coordinate value. Sorry, this is the y coordinate value and the x coordinate value, and that will be your value of sine theta and cos theta. And we'll see that. Okay, I'm just touching the surface of this concept. Is everybody okay so far? Okay. So now first see, let's try to understand why it says x and y coordinates are cos theta and sin theta. Let's double click on this. And I have drawn so many circles by now that somehow I have gotten a little better with drawing circles. See, this I bragged about it so much that this circle got distorted. But anyways, let's not worry about it. Okay, so this is a circle. This is a unit circle, meaning the radius is 1 unit. So any point, if I pick this point P, let's see what is the value of x and y coordinates. So from this point, let me drop a perpendicular onto the x-axis and a perpendicular onto the y-axis. So this distance will be x, this distance will be equal to y, okay? So my coordinates will be x, comma y. So far looks okay, based on coordinate geometry. Now, let's join the origin with this point. This is O. When I join the origin with this point, and then I'm visualizing this is a right angle triangle. O, P, let's say this is Q. Okay. So O to Q is x coordinate value. Q to P is the y coordinate value. X and y values. So far looks okay? Mm-hmm. Interestingly, this one is 1 because it's a unit circle. This is the radius. Now let's apply SOHCAHTOA here. So, and this angle will be theta. This is the angle this point is making with the positive of x-axis. This moved by theta angle to come to P. So now, if I look at sine of theta will be y over 1. Y over 1. That means y equal to sine of theta. Look at cos of theta. Cos of theta will be x, this distance over 1, adjacent side by 1, based on SOHCAHTOA. X over 1. That means x is equal to cos of theta. So you will replace this x and y, x with cos of theta, y with sine of theta. This is exactly what is all about unit circle trigonometry. Keep the phone away.
Why would you be on your phone, Sahir?
Guys, it's
Why would you
okay.
be on
I'm
your
not
phone?
complaining. I'm just saying that I need your undivided attention for next 30 minutes. That's it. Not 30 minutes anymore. 18 minutes. Okay? So, this is the whole premise of unit circle theorem. It says that any point on the unit circle, x coordinate is cos theta, y coordinate is sin theta. If you come here, what happens? Your x coordinate becomes negative, y coordinate remains positive. If your and theta changes to a point that it comes here, your x coordinate is negative, y coordinate is also negative. And that is what is all about this unit circle theorem. Now, let's try to figure out. If you have to find out value of sine 120 degree, that was not possible with trig ratios, right? Using right angle triangle. But with unit circle, I am saying that is possible. If I have to find out sine of 120 degree or sine of 240 degree or cos of, let's say, 270 degree. All these were not possible with the right angle trigonometry. So, unit circle helps us do that. Let's see. If I am talking about, this is my unit circle. If I am talking about sine of 120 degree. So, before I do that, I will, as based on my bad habit, right, I will put this table for 0, 30, 45, 60 and 90 degrees. Sine 0 is 0, sine 30 is 1 by 2, sine 45 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. And cos reverses, so it's 1, root 3 by 2, 1 by root 2, 1 by 2, 0. And sine over cos is 10. I'm just putting this table for reference, okay? Now let's say if I'm talking about sine of 120 degree. And these value of sine 0, 30, 45, these things we have proved in the previous classes. We can come back to this whenever there is a need, okay? But these are the most commonly used value of sine and cosine that you will come across very, very, very often, yeah? Now we are trying to find out sine of 120 degree. What you will do is, okay, fine. This is my x-axis, this is my y-axis. I have to go to 120 degrees. So I am starting my journey from here, and this is where I came to 120 degree. This is 120 degree now. Okay. So, and as per unit circle theorem, it says this point's x coordinate is cos of 120 degree and y coordinate is sine of 120 degree. Meaning this distance, if you find out this distance, that will be your cos of 120 degree, and this distance will be your sine of 120 degree. This is your y coordinate and this is your x coordinate. Now how much is this x coordinate? Let's try to find it out. This is 1. Let's think about it like a right angle triangle for now. Let's find out the absolute value or the length, and then we'll see if it's falling in negative side of the x-axis. We'll put a negative to it. This is falling on the positive side to it. So we'll keep the sign as is. Let's find out the magnitude. So we are talking about this angle is this here to here 90. This is 30. So this angle is 60 degree. So this angle is 60 degree, and this angle is 30 degree. I just took a snapshot from here and put it here to see this like a right angle triangle. Okay. Here, this length here to here is the radius of the unit circle. So this is 1. This is your x coordinate length along the x-axis. This is your length along the y-axis. This is your x-axis. This is y-axis. Now, here, sine, let's say sine of 60 degree will be what? Y over 1. Y over 1. That means y equal to sine of 60 degree. How much is sine of 60 degree? Root 3 by 2 from this table. How much is cos of 60 degree here? if I look at this triangle, cos of 60 is adjacent side by hypotenuse. So x over 1. So x is equal to cos of 60 degree, which is 1 by 2. So this length you found in magnitude is 1 by 2, and since this is along the negative side of x-axis, so you put a minus 1. This length you found as root 3 by 2, and this is along the positive side of y-axis, so it remains same. Now you will put here, this is x coordinate, cos of 120 degree is the value of this along the x-axis, which is minus 1 by 2. And sine of 120 degree is this length, which is root 3 by 2. And that is positive only. So you found this as root 3 by 2. Did that make sense? If you look at this whole thing, you have to visualize where it is falling on a unit circle. Then find out the length along the x-axis and the y-axis. You can visualize this like a right angle triangle without worrying about the sine and everything. Find out the magnitude and then you visualize that in the coordinate plane and see whether it's negative or positive. That is how you end up getting this value. Did that make sense to everybody or not really? Ananya, Akshita, Datta, Dev, Dheera, Kirti, everybody? Neil, Sarah, everybody? Wonderful. Ritika, you have not said anything so far, but I am assuming beta, it is relatable. Okay, now time for you guys to deal with it, because my class is never complete till I bother you guys, correct? So it's my opportunity to bother you all. I want you guys to find out two values. Find out sine of 330 degree and cos of 225 degree. And to make everybody's job easier, I will still put this table in case you guys struggle to find it. I mean, remember it. I have memorized it because I have dealt with it so many times. You guys will also end up doing it soon or sooner than later. Sine 0 is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Sine root cos is 10. So I want you guys to find out sine 330 degree, cos 225 degree, and let me add more spice to it. Find out tan of 330 degree also. Give it a try. And do it the dirty way. No internet search. I want you guys to get your hands dirty. Okay? Try it and let me know. You guys have 5 minutes for doing it. Maximum.
The first thing is small. Don't you just have to like plus or minus 360 if it's rectangular?
So remember one thing. It's always about when you are measuring the theta, you have to go in the anti-clockwise direction. That is how you measure the angle. Subtracting from 360 would make you think the other way around.
Subtracting from 360
You
would.
have to subtract and add it.
You have to subtract and add it?
Yeah.
And?
Okay, deal with it. I want you guys to find it out, and then you guys have maximum 5 minutes. I'm keeping 4 minutes for myself so that I can do that towards the end for everybody to be on the same page.
Okay. What's the answer?
For sine of 330, it's 360.
Okay. So what's tan and 330?
That's the same thing.
So then what's closest to 225?
360 minus 225.
No, so what is the answer?
Right. It's negative 35. Mhm. 360 plus 2. I can't do this after that.
Can I assume everybody is giving it a try? Ananya, Chita, Hana, Dev, Datta, yes Vijay. You got it? Alright. How much did you get?
What is like list all of them or?
All of them.
Okay. So 0, root 2 over 3, 1, root 3 over 1, 0.
One more time, sir. This one is how much?
0. Huh?
How much is this one? Sine 330?
Oh, never mind. That's just root 2 over 2.
Root 2 over 2.
Root 2 over 2.
And how about this guy?
That's also negative root 2 over 2.
Okay. And 10 330?
2330 should be just negative 1.
Okay. We'll see. What happened? Praneeth is very quiet today.
It's because it's ChatGPT.
No chatting. Give me the answers. Though I don't care about the answers, but yeah, I still want to see the answer. How you are getting, how you are navigating towards the answer. That's more important for me. Nikhil, Achita, Vishal. Oh, Praneeth's mic is broken.
That's a lot. That's a lot.
Okay. Riya, me, Zara.
So I'm gonna text
I'm waiting for you guys to give me some interesting answers. What did you guys do?
Raj did
Plus
plus minus
number.
360.
I'm sorry?
Raj did plus and minus 360 for everything.
Plus minus 360 for everything. So what did you get?
For sine 10, I got negative 30 and 690. And for cosine, I got 585 and negative 35.
But that is not the value, right?
We
Like sine 60 root 3 by 2. So how much will be sine 330? That's what I'm trying to find that value.
It's either negative 30 or 690, so that's somewhere in between.
Not tough boy.
Not that way. Okay. Get a notebook for yourself now.
I'm gonna use this.
Okay, Achita, what did you get?
First one is 1/2.
I'm sorry, Vita?
The second
So
one.
I just see the
Which
value
one's the
for
second
each degree
reference
of
number?
10.
Which one's
No,
the
so
second
you have
one?
to tell me is how much is sine 330 degree, how much is cos 225 degree, and how much is tan 330 degree.
Okay. I thought we were solving for the 10 and the
Right. Okay, so just because we have only 5 minutes, okay, and I see a lot of silence, which gets me a little worried. So what I will do is, I will probably do it. I don't give you guys assignments because you guys are already grown up. But this week I might choose to give you guys some assignment because I love dirty hands. I want you guys to get your hands dirty, okay? So look at this, okay? Next 5 minutes, guys, everybody. Next 5 minutes, I want you guys to hear my speech with full attention. Okay? I'm trying to, what you are trying to find out? Sine 30, sine 330.
Sine 330, cos 225, tan 330.
Tan 330. Since I have to find out sine 330 and tan 330, let me do it together. 330. I start from here. This is 90 plus 90, 280 plus 90 270 plus 60. I came to this point. Now this total angle is 330 degree. Guys, no, don't do that. This angle from here to here 30 and here to here 330. So that is how it makes one complete circle of 360. Okay. So I have come to this point. This point's x coordinate will be cos of 330 and y coordinate will be sine of 330. If I can find out this length, that will be cos of 330. This length will be equal to sine of 330. Let's see what happens. Now, when I have come to this point, let me drop a perpendicular from here to here. And this is my right angle triangle. This is my right angle triangle. This angle is 30 degree. This is the radius 1. And this is y, this is x. Okay? Now let's find out x and y, and that is what will get us the sine 30 and cos 30. Now here, if this is your right angle triangle, this is your adjacent side, this is the opposite side for this angle. So x over 1 will be equal to cos of 30 degree. We are trying to find out the absolute value and then we will look at the side, that's all, in this triangle. So see, what is happening here is unit circle tells you that you navigate along this unit circle, and once you land at that point, find out the absolute value, and that is it. So here in this triangle, this doesn't say 330 degree, we never have a triangle of 330 degree angle. So this is a derived triangle from this whole thing, which has this angle 30 degree, this is 1, this is y, this is x. X over 1 is cos of 30 degree, y over 1 is sine of 330 degree. I'm sorry, sine of 30 degree. So y over 1 equal to sine of 30 degree. Sine 30 degree we know is root 3 by 2. So y is equal to root 3 by 2. X is equal to cos of 30 degree. Cos 30 degree is again root 3 by 2. What am I doing here? Sine 30 is 1 by 2. That's why I was thinking how come my sine and cos value both are same. Root 3 by 2. So x length, this length is root 3 by 2. Y length is 1 by 2. Sine 30 is 1 by 2. If you look at it here. So this is 1 by 2 and this is positive. So cos of 330, we don't have to find cos of 330. We have to find out sine of 330. This is 1 by 2. This magnitude is 1 by 2, but this is along the negative side of y-axis, so this is minus 1 by 2. So here sine 330 degree is equal to minus 1 by 2. We have to find out tan of 330. Tan of 330 is sine of 330 by cos of 330. Sine of 330 we got as minus 1 by 2 divided by root 3 by 2. So this became minus 1 by root 3. Yeah? Just 1 second. Walk slowly. Slow. Yeah. Come and sit down. No drama. Come and sit down. Okay. And don't kick this thing. Move your feet without kicking my laptop.
Oh.
You guys are not watching your steps. Okay. So from this one we found sine and cos of 330, and tan 330 is nothing but sine over cos. That's it. Similarly, if you have to find out cos of 225, how will you do it? 90 degree plus 90 degree, 180 degree and 45 degree more. You land here. This point is cos of 225 degree, comma sine of 225 degree. Find out the x length, this will be negative. Find out the y length, that will also be negative. So this is a triangle now, where this length is 1, this is x, this is y. X over 1 is equal to cos 45 degree for this triangle. y over 1 is sine 45 degree. Both are 1 by root 2. So cos 225 degree will be 1 by root 2. This length in the negative side. So 1 by root 2. Can you guys stop making that extra funny sound? Who's making that sound? Don't make yourself, don't point fingers at others. Alright? So this, if you look at the whole thing, unit circle just helps us decode things in an easier way. Intuitively you can see where I am landing, and then at that point find out the x and y length applying basic trigonometry, and you should be able to take it forward. So tomorrow if somebody says find out the value of 820 degree, you'll say okay, one circle 360, one more circle 720, and then 100 degree more. And for this 100 degree, if you can find out the x and y value, somebody is still making sound. Is that you? Don't make that sound, because that gets my attention diverted. So basically you'll always look at where you're landing in the unit circle. Once you land at that point, then visualize that right angle triangle, find out the absolute length, and that's it. It enables you to even find out the sine and cosine value of angles as big as 1500 degrees, which you cannot do by using simple right angle triangle. Does that make sense?
Yeah.
I don't appreciate unnecessary talks. You are not here physically. Your class has not started yet. Alright? Does that make sense to everybody? For whom it is relevant? With that being said, I'll let you guys go and we'll meet again tomorrow. Alright? Bye bye. Bye bye. Yeah, bye bye.